Lights on. Hi friends, today's topic is electrifying. It's electricity. We are using electricity all the time in our homes, schools, offices, industries. In fact, I can't make this video without electricity. But do we really understand what electricity is? What is the magic in the wires that helps to run our lights, fans, computers and machines? And do you know what these terms mean? Electric circuit, electric current, electric charge and electric potential? Don't worry, we are going to discuss electricity in a practical way using this simple setup. And I'm going to make electricity really easy for you. After you watch this video, try solving the quiz and the top 3 questions on this topic. Links are given below the video. Now let's explore electricity with the help of a simple experiment. We know electricity is needed to light up a bulb. For the experiment, I'm going to use this small bulb. What are the things needed to make this bulb glow? That's right, we need some wires and a switch, and we need cells to supply electricity. I'm going to use this battery containing 2 cells. Let's take a look how these things are connected. As you can see, the positive terminal of the battery is connected to the switch using this red wire. And then the switch is connected to the bulb using this wire. And the bulb is connected to the negative terminal of the battery using the black wire. Now let's turn on the switch. And the bulb is glowing. We have electricity flowing in these wires. Let's use our simple experiment to understand electricity and these different electrical terms. This entire arrangement of the cells, wires, switch and bulb through which electricity can flow is called an electric circuit. Something is flowing in the wires that causes the bulb to glow. This is called electric current. The wires are called conductors since they allow electric current to pass through easily. Okay, electric current is flowing in the wires, but what exactly is moving in the wires? Electric charges are moving in the wires. So electric current is the flow of electric charges, or it's the motion of electric charge. Who in the circuit causes the electric charge to move? That's right, it's the cells, the battery. Cell is a source of electric potential, or what is also called voltage. If there is no electric potential, if I remove this cell, there will be no current. The bulb will not glow. So electric potential is needed for the flow of electric current. Now you have a basic idea of what these electrical terms are. Let's look at each of the terms in detail. Let's start with electric circuit. As we discussed, this entire arrangement of the cells, wires, switch and bulb through which electricity can flow is called an electric circuit. This is a very simple electric circuit. The electric circuit can be represented using a simple diagram called a circuit diagram. You might have seen circuit diagrams in your textbooks. Let's draw the circuit diagram for this circuit. A cell is represented using these 2 lines. The longer line represents the positive terminal and the shorter line represents the negative terminal of the cell. Since there are 2 cells here, let's draw another cell. A group of 2 or more cells is called a battery. So this is a battery containing 2 cells. A bulb is drawn using a symbol like this. Some books may use a different symbol like this for the bulb. The connecting wires are represented by simple lines. A switch is shown using this symbol which looks like a gate. When the gate is open like this, it's called an open switch. Here the switch is off. Since there is no closed continuous path, the current cannot flow. The bulb will not glow here. This is called an open circuit. Now when the switch is closed, there is a closed continuous path for the current to flow. The bulb will glow. This is called as closed circuit. So remember, open circuit means off and closed circuit means on. There are many other circuit symbols, but we'll look at those in a different video. Let's place electric circuit on our concept board. An electric circuit is represented in a simple way using these circuit symbols. When the switch is on, the circuit is closed. Electric current is flowing in the wires. Let's imagine the wire to be a pipe. Just like water flows through a pipe, similarly, current is like water flowing through the wires. But there's a difference. Water pipes are hollow. But have you noticed that wires are not hollow? They are made of solid metal. There's an insulation around the wires, but the actual wire is just made of solid metal, like copper or aluminium. Now, do you know what is flowing in these copper wires? That's right, electrons. Electrons are these tiny charged particles. Electric current is the flow of electric charge. So if there is no flow of electric charge, then there is no current. So electric current is electric charge in motion, and this is called current electricity. There's another type of electricity which is called static electricity. The word static means at rest. In static electricity, the electric charges are at rest. They do not move continuously. Now, what are some examples of static electricity? That's right, lightning is static electricity. Or if you rub a comb on dry hair, then the comb can attract bits of paper. How does it do that? Because the comb gets charged by friction. This is also an example of static electricity. But in this video, our focus will be on current electricity, where the electric charges are in continuous motion. They are continuously flowing. As we discussed, electric current is the flow of electric charge. Now, what do we mean by electric charge? Electric charge is a fundamental property like mass. Just like a body can have a certain mass, a body may also have a certain amount of charge. You may have heard that charges are of two types, positive and negative. So a body can be positively charged, negatively charged, or it may be neutral, having no charge. Now, do you know what are the fundamental particles that carry charge? Hint, they are the particles inside an atom. That's right, it's the protons and electrons. Protons are positively charged particles and electrons are negatively charged particles. An atom also contains neutrons, but the neutrons are neutral. Neutrons have no charge. Now, the charge of a proton is equal and opposite to that of an electron. So, an atom is neutral since it contains equal number of protons and electrons. So, the positive and negative charges, they cancel each other, and the atom itself has no charge. So, the question is, then how do we charge a body? A simple way is by rubbing two bodies of a suitable material. For example, if I rub this plastic comb on my dry hair, then the comb gets charged. The comb gets negatively charged and the hair gets positively charged. Because on rubbing, due to friction, electrons from the hair get transferred to the comb. The comb has extra electrons now, so it is negatively charged and the hair is positively charged. A body which has more electrons than protons is negatively charged. And if a body has more protons than electrons, then it is positively charged. If it has equal number of protons and electrons, then the body is going to be neutral. The symbol Q is used to denote electric charge. Now, do you know what is the SI unit of electric charge? That's right, it's Coulomb. Carefully note the spelling. And in short, it's written as capital C. An electron carries a very small amount of charge. It's minus 1.6 into 10 to the power minus 19 Coulomb. And the charge of the proton is the same value, except it's positive. So the proton's charge is going to be plus 1.6 into 10 to the power minus 19 Coulomb. Let's put electric charge on our concept board. Remember, the symbol Q is used for charge and the SI unit is Coulomb, denoted by capital C. As we discussed, electric current is the continuous flow of electric charge. Now, what charge is flowing in the wires here? Protons, electrons, or both? That's right. The correct answer is it's the electrons in the wire. Now, where do these electrons come from? These are the electrons present in the copper atoms in the wire. They are the outermost electrons, known as valence electrons. The protons are tightly bound inside the nucleus of an atom, so they can't move so easily. The valence electrons, on the other hand, are so loosely bound to their atoms that they are freely roaming around in the copper wire. That's why they are called free electrons. Substances like metals have a large number of free electrons. So they allow electric current to easily pass through. And these are called good conductors of electricity, or simply conductors. But those substances which do not allow electricity to pass through easily are called bad conductors or insulators. Now, what are some examples of insulators? Correct. Materials such as wood, rubber, plastic, these are examples of insulators. Now, as we were discussing, a wire is a good conductor of electricity since it has a large number of free electrons. Now, if the wire is not connected to a battery, the free electrons are moving in a random way. So there is no electric current. But when the wire is connected to a battery or to an electrical supply, the free electrons start flowing in a particular direction. Do you know what is the direction of electric current? This is a bit confusing because there are actually two directions of electric current. The typical direction is called conventional current, and it is from the positive terminal of the battery through the wires and into the negative terminal, as shown here. Let's mark the direction of the conventional current in our circuit diagram. But do you know that the real direction of current is actually opposite? It's called electronic current. The electrons are negatively charged particles and they flow from the negative terminal of the battery through the wires in the circuit and into the positive terminal of the battery. Let's also mark the direction of electronic current in our circuit diagram. As you can see, it is opposite to the conventional current. Why this confusion? Why two directions of electric current? It's because electricity was discovered before electrons. When electricity was discovered, they thought that it is due to the flow of positive charges. But later they discovered, oops, it's the negative charges, the electrons that are actually moving. However, they did not change the direction of electric current. So when we mark the direction of current, it is the conventional direction that is used, from the positive terminal to the negative terminal of the battery. Electric current can be measured. We can give a numerical value to the current. Electric current is defined as the rate of flow of electric charge. So the formula of current becomes charge divided by time. The symbol I is used for current. So we have the formula as I equal to Q by T, where Q is the amount of charge that is flowing and T is the time. Now what is the unit of current? It's going to be coulomb per second, and this is called amperes, and it is denoted as A. For example, if 5 coulomb of charge is flowing per second, then the value of current is going to be 5 amperes. We can measure the current using an instrument called an ammeter. The instrument looks something like this. Let's place electric current on our concept board. I is the symbol for current and the unit is ampere, denoted by A. Now we know what electric current is. It is the continuous flow of electric charge. But who causes the electric charges to flow continuously? That's right, it's the cell. If we remove the cells or if they get drained out, then the bulb will stop glowing because the current will stop flowing. So for electricity, we need a cell or a battery like this. A battery is a collection of 2 or more cells. Other sources of electricity are the mains in the house or an electric generator. We say that these things supply an electric potential or voltage, which causes the electrons in the wire to move. Electric potential can be thought of like an electric pressure, which is pushing the electrons and making them move in the circuit. Just like we have to do work to lift a body, so if I take this ball and I lift it from this point to this point, similarly, the battery has to do work to move electric charges from one point to another point in the circuit. A more commonly used term is electric potential difference, or simply potential difference. It's also known as voltage. The potential difference between 2 points in an electric circuit is defined as the amount of work done in moving a unit charge from one point to the other point. Potential difference is defined as the work done per unit charge. The symbol of potential difference is V, and the formula is V equal to W by Q, where W is the work done and Q is the charge. Let's say 3 joules of work needs to be done to move 1 coulomb of electric charge. So the potential difference is going to be 3 joules per coulomb, and joules per coulomb is called volts. The symbol is V, and this is the unit of potential difference. It's volts. Now I'm sure you've seen a simple AA cell like this. What is the potential difference between the positive and the negative terminals of this cell? That's right, it's 1.5 volts. If you look closely, as you can see it's written on the cell, it says 1.5 volts. So the potential difference between the terminals of the cell is 1.5 volts. Do you know what is the potential difference that you get at your home? It actually depends on the country you live in. For example, in India the voltage is 220 volts. In the United States it's 110 volts. These values are much higher than the simple cell, which was only 1.5 volts. So we need to be careful when using electrical equipment, and we should not touch the switches with wet hands, since the voltage is high and we can get a shock. The potential difference can be measured using an instrument called a voltmeter. The voltmeter in the lab looks something like this. If you connect the voltmeter across a cell like this, it will read 1.5 volts. Let's place potential difference on our concept board. V is the symbol used for potential difference, and the unit is volts, which is also denoted by V. Friends, I hope the concept of electricity is crystal clear to you now. To revise the concepts, you can go to my website manochaacademy.com and go try the quiz and the top 3 questions for this video. To make it easy, I'll put a link in the description below. So just click on the link and write the answers for the top 3 questions, and I promise to reply to them as soon as possible. And if you haven't subscribed to my YouTube channel already, go hit the subscribe button right now. You can like and follow my Facebook page. And do check out my website for more videos like these and for the quiz and the top 3 questions for this video. Thanks for watching.